Okay, Assalamualaikum and good morning. So today I would like to continue our class with the last part for chapter 4, which is expected number of years lived between hx and x hx and x plus n, and the notation is NLX. So this is the second new notation that we found in this chapter 4. So last class we found TX, the new notation. So the second one is NLX. So actually NLX is also from TX. So NLX is TX minus TX plus N. So if you still remember TX versus EX, the difference. So TX, expected future lifetime for LX group of survivors. So this is for individual. EX for individual. So LX actually is the term, is the interval from X to X plus N and LX. So we use TX minus TX plus N. So it's same as TX formula, but this time we use expected future lifetime for interval X to X plus N. So the upper bound is N. So for proving part, don't worry about proving part. You just have to know the formula, these three things. 1, 2, 3 equation. Okay. Okay, if that this one from X to X plus N, NLX. So for one interval only, we use LX. So meaning that here is actually 1 here. So the upper bound is 1. So that's only the difference. So TX minus TX plus 1, and the upper bound is 1. And another thing is, okay, if we want to use LXEX, so it meaning that it have to times LX with EX. EX plus 1. Or we also can write down as LX EX to 1 term. So the third one. Okay. Okay, this is corollary. So you can see the relationship between TX and LX, EX, and LX. So this is for whole life, and this is for interval X to X plus N. Okay, don't worry about proving. You just have to know the formula. So this is for summation, is for discrete. So this is the relationship between discrete and continuous. Okay, we have 3 as well. 1, 2, and 3. Okay, the center rate, the last one. Center rate rate denoted as mx, but bear in your minds mx is not equal to mu x. So mu x is force of mortality. So mx refer to center rate. So mx meaning that 1 in front, it's from lx to lx plus 1. So you want to find the center rate between Lx to Lx plus 1. So only for one interval. However, for second one, Nmx from interval from Lx to Lx plus N. So this is for one interval, this is for N, and yes. So this is N, M, X. So now we try example 7. Example 7, L10. So we try first with L10. Set. Draw. Okay, we try first L10. So you are given the information of L naught equal to 10,000 and force of mortality is constant mu equal to 0.01. So L10, what's the formula for L10? It is, so there is no numbers in front, so meaning that it is 1 here. So the upper bound is 0 to 1. We have to integrate Lx plus t. So x here is 10. So we straight away write down here is L10 plus t dt. So how to find the L10 plus t? Okay, L10 plus t. How to find this one? Okay, this is constant force. Remember, Tpx for constant force is E negative mu T. So Tpx is actually equal to Lx plus T over Lx. If we convert it in terms of life table in terms of Lx. So it is equal to E negative mu T. So we get Lx plus T is equal to Lx times E negative mu T. Okay, we don't have Lx, so how to play around with this equation? So, okay, P naught, meaning that the newborn probability of survivors from 0 to x plus t is equal to Lx plus t plus 0 over L naught. So, E negative mu x plus t, since here is x plus t, so here is x plus t, is equal to Lx plus t over L0. So then E negative 0.01 x 10 x plus t is equal to Lx plus t over 10,000. So Lx plus t is equal to 10,000 times E negative 0. Okay, you may get confused here. Never mind, we cancel this. I show you slowly. Okay, so okay, so from here Lx plus t over L naught. So in this equation, our constant of our force of mortality is 0.01. So x plus t is equal to Lx plus t over L naught is 10,000. So our L naught is 10,000. Okay. So we substitute for Lx plus t is L10 plus t is 10,000 times E negative 0.01 find L10. So we substitute L10 with 10,000 times E negative 0.01. Sorry, this is 10, isn't it? 10 plus T, sorry. 10 plus T, yes. So 10 plus T. dt with respect to dt. So we can take out the constant. So the constant is 10,000 E negative 0.01 times 10, and then we just leave the exponential with respect to t only. So we integrate this only. So top. The final answer is tada, 900.3.2827. Okay. This one is actually Lx. Lx equal to 10,000 E negative 0.01x. Okay, how? Okay, Lx is equal to Lx time. Remember, we also can use this one. Okay, since it is only one interval, so only one. So Lx can times, if we write down Ex in Tpx, so it is integration of Tpx. Okay, so Lx 0,1 Tpx is E negative 0.01 T dt. So from here we get what is Lx? Lx we can get from Lx over L naught. So XPO is E negative 0.01x, since it is constant. Lx over L naught is 10,000. So actually Lx is 10,000 times E negative 0.1x. So it's same as here. Yep, this one. Okay, so this is actually Lx. Here we can get from here. Just only I would like to explain more so you can see it more clearly, I hope. Okay, we try to solve B. So B is center rate for M10. So no number before M, so meaning that only 1. So 10 to 11. So L10, L11. So you want to find the center rate between L10 to L11. Again, from previous question, we get Lx is equal to 10,000 E negative 0.01x. Okay, so refer to previous page. I already showed it to you. So we just have to find L10. So we substitute L10 in this formula. We got it from A. So we substitute 10 here. So we will get 9048 0.3741, and then we substitute L11 inside, so we get, and the answer for L11 is 8958.3414, and then L10 we got from A is 9003.2827. Then we can find the center rate. Center rate is L10 minus L11 over big L10. So the answer is 0.01. Okay, the last one. Okay, the last one, we have to find T10. How to find T10? T10, okay, the formula is Tx equal to 0 to infinity Lx plus T dt. So T10 is equal to 0 to infinity L10 plus T dt. So our L10 plus T is, from previous question, 10,000 times E negative 0.01 10 plus T dt. So you solve the equation, you will get the final answer is 904837.41A. Okay, so we complete chapter 4. If you have any question, you can ask me personally. Thank you, guys.